Okay, today we're doing basically, I'm going to call it part 2. So this is R1, which is review, I'm sorry, it's R2, review lesson 2, and it's part 2, all right, to this. So let's go to the math page, and let's get rolling here. All right, let's see what the first thing, again, I told you in the little preview here that it's real basic. And so here's a word that we're going to be using a lot, and it's called a variable. Somebody real quick, just tell me a simple basic definition for a variable. Variable is what? Off the top of your head, what do you think? It's a letter that does what? Yeah, that replaces a number. That stands for a number, okay? That represents a number, okay? So it's just basically a letter that represents a number. What's like everybody's favorite variable in math? X, right? Okay, so we use X a lot. I don't know why. They just do. Y is used quite a bit. You can use any letter. In fact, the more math you do, they get out of the regular English alphabet and they go to the Greek alphabet. All right, you've already done a couple Greek things, haven't you? What's this thing? But is this a variable, though? No, it's not a variable. What is it? It's 3.14159, blah, 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 right? It's a constant. All right, so that's actually a constant, which means it's a number that just stays the same all the time. So pi, even though it's a letter, it's a Greek letter, it actually represents a number. You could use A a lot, you could use B, and blah, blah, blah. There's a ton of different variables that you could use. Like a Greek letter, when you did geometry, I don't know if your geometry teacher taught you this or not, but an unknown angle. Do you remember the letter that we use for an unknown angle? Looks like this. You ever use that thing? Do you remember what the letter was in the Greek alphabet? Theta, right. Okay, some people say theta. It's Theta. What it looks like theta, but I say it's theta. All right, so that's a very common, like if you had an angle like this, a lot of times they would call this angle theta. Does that ring any bells? Anyway, that's a variable. Okay, so you can have Greek letters. Like what's the most famous Greek letter floating around the news today? The blank variant. What is it? The delta. Delta is actually a Greek letter of the alphabet. You know that? All right, so that's what it is. What's a good biblical Greek letter? First and last. What is that? I am the what? Alpha and omega, right? The first and the last. So that's the alpha is the first letter of the Greek alphabet. Omega is the last letter of the alphabet. So you know some Greek a little bit, right? All right, so enough of that. So let's talk about a constant. We already mentioned it briefly. So constant could be what? Somebody just give me a constant. We've already mentioned one, but you can use that one. I don't care. Use a different one. 5. Very good. 5 is a constant. 5 is 5 no matter what. It's always 5. Okay? It doesn't represent 3. It doesn't represent -7. It's always a 5. Everybody got that? So any number could be that. Pi, right? That's a constant. 3.14159. And I don't know the rest of it. That's all I know. All right? I had a kid one year, my early year of teaching, he claims he knew up to 100 decimal places for pi. I don't know what the reasoning for that would be. I don't, that's great and everything. He rattled them all off, but I had no idea if he was right. Your calculator only goes up like, I don't know what, 8, 9 decimal places, something like that. So I wouldn't even know. But if you look at online, you could look up online and you can see pi, see how far it goes out. But anyway, that's still a constant. All right. What about this? An algebraic expression. So an algebraic, sounds fancy, algebraic expression. And you're going to see that term quite a bit in here. You've seen it already in Algebra 1, Algebra 2, that kind of stuff. But an algebraic expression is not just one single letter or number. It's like a combination. So like x plus 3 would be an algebraic expression. It's a combination of a variable and a constant. Does that make sense? Another example they give in the book, if I could read it, I think it says 1 minus t. All right, that would be an algebraic expression. It's, again, a combination of variables and constants. All right, so let's do a real example. And let's change to, I don't know, what color? Green? We'll try green. So this is example 5 in the book. So if you look up in the book, example 5, let's see what we got. So it says evaluate. You'll see this a lot. It says evaluate And then they give you like 4 different expressions. So I'll just write the first one, x plus 3y. And then it says if. Now, we can't evaluate this just by itself. If I just said evaluate this, can you do anything with this? No, you can't add them up because they're different variables. You don't know what x is. You don't know what y is. So you can't really figure out what this is equal to, can you? There's nothing you can do with that. You're stuck. But it says if. And what do you think they're going to tell you? They're going to tell you what do you think? What x and y are. That's right. Okay, they're going to tell you what x and y are. So this says if x is 3 and y is -1. All right, so we're going to evaluate this if x is equal to 3 and y is equal to -1. So what we're going to do is look at this. This is an algebraic what? Expression, okay? So what we're going to do, I call it plug and chug. You ever hear that? I had a professor in college used to say that all the time, so I've been saying that for 25 years as a math teacher. Plug and chug, which means you're just going to take what x is equal to, you're going to plug it in for x right here. So what is x? 3. Put a plus sign. Now, this is a constant, that 3, so I'm just going to keep that. Now, you have to understand what's going on here, okay? And you know this from Algebra 1. If you have a number right next to a letter, nothing in between, what does that mean they're doing to each other? They're multiplying, okay? So for multiplication, I put a parentheses. Don't put a dot. Don't put a little x. Put a parentheses, okay? That's how big kids do it in algebra, for the most part. There will be times where you do x's and dots, but a lot of times you put the parentheses. So you could put a y in there. So what's y equal to? It's -1. So you stick a -1 in here. And you just have to do the, what it asks you to do. Let's go back in time a little bit and talk about order of operations. Do you remember order of operations? What's a way to remember? Yeah, PEMDAS or whatever you say. Some people say that. What's the whole thing? It starts with P, starts with please what? Please excuse what? My dear Aunt Sally. All right? Do you remember that? Some people say PEMDAS, whatever. Please excuse my dear Aunt Sally. Okay? What does this mean? What does the P represent? Talk to me real quick. Parentheses, keep going. Okay, now, I know kind of Facebook is out for you guys. You don't do Facebook stuff. Maybe this stuff goes around on Instagram. I have no idea because I'm an old guy, so the only thing I have is Facebook. But every once in a while, there's these little math problems. Do they do that on Instagram? All right, and these math problems, they say, do this in your head. And everybody comes up with these different answers, okay? And it's basically, is everybody listening? It's basically the order of operations, okay? And here's where everybody gets stuck on the order of operations. It's right here, the multiplication and division. It looks like you always do multiplication before you do division, doesn't it? But not really. The multiplication and division are kind of lumped together, all right? And same thing with the addition and subtraction. The addition and subtraction is lumped together. Basically, you do this. You do any multiplication and division before you do any addition or subtraction, all right? And if there's multiplication and division in it, you always go from left to right. That's what a lot of teachers... What's going on out there? Is that a hose? Anyway, that's crazy. It's just a lot of... I don't know. Is it a pipe that busted? Can you tell? You can't see where it's coming from? No, don't go to the window. Everybody sit down. Sit down. There is a person. Okay, I'm just making sure it's not a pipe or something that we had to call the school. So it is a person. All right. I should have never even told you because you wouldn't even notice. All right, let's take a look at this. So in this situation right here, this pink one right here, what do we do first? Do we go 3 plus 3 is 9? No, because we always do multiplication before addition. So you do the multiplication first. So this you do first. So we'll keep that there. We'll keep that there. 3 times -1 is -3. So you add those up. What's 3 plus -3? It's 0. And so that's our answer for that. Pretty simple. Do you agree? Tell you what. I'm going to write a couple more down, and I want you to try them. I'll give you a minute to do it. It shouldn't take you too long. So everything is evaluated. So I'm going to give you a couple more. And the x and the y stays the same. X is always 3. Y is always -1 in this situation. So here's an example. 5xy. So evaluate that. Here's another one. 3y over 2 minus 2x. This is a y. It's not a very nice looking y. There you go. It looks a little better. So it's 3y over 2 minus 2x. And then one more. We learned this yesterday. Plus y. And it's in an absolute value symbol. Okay? I'll give you about a minute. Go ahead and work on those. I can't go back and pause. I can't pause the recording. For some reason, this program doesn't let you do that. So if you ever go back and watch this video, you have to sit or just scroll through it, right? Just fast forward it while we're just sitting here like this. We're almost done? Tell you what, I'm just going to see what the answers are, and if you have a question on them, we can go over them. Hopefully we don't have to do all three of them. So what'd you get for number, or for this one right here? We'll call this B. So what'd you get for B? Anybody? Somebody? Okay, Josiah, what'd you get? Just tell me what your answer is. Negative 15. Anybody agree with him? Yeah, I do too. So it's negative 15. All right, so you just multiply all that stuff together. That was the easiest one, definitely, wasn't it? Yeah. All right. Anybody want to volunteer for letter C? Who got C? All right, Peyton, what do you get? Okay, but simplify it a little further. What's a negative divided by a negative? It's positive. So how would you say your answer? Just 3/4, okay? And you're right, technically you would get a negative on the top and a negative on the bottom, but negative divided by negative is positive, so we make sure we write it as positive. Now, if this was a quiz or a test, and you wrote negative 3 over negative 4, I'd probably still give it to you, all right? But you need to make sure that you simplify it as much as possible, all right? We're good so far. Sounds like you're doing well. What about D? Anybody finished D yet? All right, Matt, what'd you get? 13. Anybody agree with him? Yeah, I do too. So 13 is the answer for that. Any questions on how you got one of these? Maybe you didn't get it. Look back and see what you did wrong. Now, why I said that, here's a little tip for doing your homework. So everybody listening? When you do your homeworks, you do have the odds in the back, okay? Are the odds in the back so you can just write down the answers and turn it in? No, okay? Now, do people do that? Yeah, of course. Will I accept that? No, I won't, okay? We talked about that the other day, okay? I will not accept just a whole bunch of answers written down and turned in. I'll give you a 0. You'll get 0%, okay? I want you to show your work. So here's the deal. You do the problems, okay? Do them all. Or maybe do a little section of them, okay, before you go to the next section. They're kind of broken down into little sections. So do a section of them. And it might only be like 3 or 4 problems that you have to do, right? After you finish those, then you flip to the back of the book, a little bookmark back there. Check your answers, okay? If you got them right, cool. Go on to the next section. If you got one wrong, do you say, forget it, I'll just keep going? Well, do you say it? Yeah, probably. But should you say it? All right, no. All right, so what should you do? All right, let's say you got negative 16 for this. All right, what should you do? You should go back, all right, look at the problem. You know what the answer is now. Go back and try to figure out what you did wrong. All right, that's how you learn. Okay, don't just, you know the phrase, practice makes perfect? Well, that's not always true. Okay, it's not just practice. If I just do these problems and I get every single one wrong, is that going to make my work perfect? No. Perfect practice makes perfect. Okay, so that means if you do a problem, check the answer, always check the answer, and if you get it wrong, go back and try to figure out what you did wrong. That's super important. Everybody with me on that? Okay. Let's see what time we get out here. 50. Oh, I got plenty of time. All right, let's keep going. Let's see what this next thing is. Oh, okay. Let's change colors since we're doing something a little different here. A little lighter purple. All right, we're going to find the domain of a variable. I don't know if you did this too much in Algebra 2. Do you remember ever doing this? Talking about finding the domain? Yeah. Did you? Okay. It's been a long time since I taught Algebra 2, so I forget. But the domain. Algebra 1, I don't think they ever asked you that. Geometry, they definitely didn't ask you that. But starting in Algebra 2, then you start getting into trig and college algebra and stuff like that. They ask for the domain of a variable. So here's the definition of the domain of a variable. Write it down. It's the set of variables. The set of variables. I'm sorry, I lied. It's not variables. I skipped to the second part of the definition. Values. It's the set of values. Sorry about that. So it's the set of values that a variable may assume. And you're like, what in the world does that mean? That doesn't help me. The variables that a variable assumes. Okay, so basically, let's take the variable just x, all right? Let's try this color. Just the letter x. I thought I changed colors. Let me try to change it again. Okay, let's change it. All right, just the letter x. Now, this seems like a dumb question, but what kind of numbers can x be? Can they just be positive numbers? No. They could also be what? Negative numbers. Are they just integers, like positive whole numbers and positive negative numbers? No. It could be a fraction. It could be a decimal. What about a square root? Could it be like x is equal to the square root of 2 or something? Yeah. Is there any number that x cannot be? There's not. X can represent every single number that you can think of. Any real number. Let's say that, okay, to be specific. It could be any real number that you can think of, all right? But what about this? What about that? What can x not be? So it cannot be 0. Would you agree? All right. So x cannot be equal 0. Why not? Why can x not equal 0 here? Because you can't do what? You can't divide by 0. I think that was like our first lesson in this class, wasn't it? Okay, you cannot divide by 0. That's basically, in a very, very simplified nutshell, that's basically what it means to be the domain of a variable. Okay, the domain means that if it says, find the domain of this expression, okay, the domain means what can x be or what can x not be. So basically, they would write it like this. This is kind of like the fancy college way or the fancy math way of saying the domain. So I'll put D for domain equals, and then I put a little bracket thing, whatever you call that thing, and then you put x can be all the real numbers, and then you put a line here. This is not absolute value. It means such that, okay? So the domain can be every number. So the domain can be all the x's except for what? 0. And then you would close it like that. That's the fancy way you write domain. Isn't that weird? Okay? So you write domain equals, D equals, and a little brace thing, then x such that. So that little bar right there means such that x cannot be 0. So this x means x can be anything, but here's your exceptions. That's basically what domain is asking you to do. Find the exceptions. Find what that variable cannot equal. Okay? Let's do another one. Let's do find the domain. It says, I'm not going to write it out, but it says find the domain of x in this expression. It's kind of the same thing. Kind of. X minus 2. So it says find the domain. So D equals. I'm going to put the brace. I'm going to put x, since we have an x right here. Now, if this was y or a or b, you wouldn't put x here. Everybody understand that? you would put whatever the variable is in your expression. So it happens to be x, so I put an x right there, such that. Now, can x be any number in the world? Can x be 0 down here? Why yes? Because 0 minus 2 is what? Negative 2. Can you divide by a negative 2? Sure. 5 divided by negative 2 is a number. It exists. It's okay. Everybody with me on that? So it's not just that x can't be 0. What can't be 0? The what? The denominator. That's right. A lot of D's going on here, okay? It's the denominator. The bottom of the fraction can never be 0. Everybody got it? So that means, how would you do the math? Now, this is pretty easy because we can kind of do it in our head. What would x have to be in order for the denominator to be 0? A 2, right. So 2 minus 2 would be 0. So is x allowed to be equal to 2? No, it can't be 2. So this is what I would do. This is how I would show the math, okay? Because sometimes you're going to have a really more complicated expression down the bottom than just this easy one. So what I would do, I would say, this is my work, okay? This is showing my work. I would say x minus 2 cannot be equal to 0. Would you agree with that? Right? So the denominator cannot equal 0. And so now let's find what x cannot equal. So let's do some simple math. What do? Add a 2 to both sides, add a 2 to both sides. I get x cannot equal what? 0 plus 2 is 2. So x cannot equal 2. So we come up here and we put x cannot equal 2. And then we close it with that little brace looking thing. And there you go. And that's basically the work you can do. On something like that, that's really simple. You can kind of do that in your head a little bit, all right? But that's what your answer is. That's how they want. I think that's how they write your answer in the back of the book. Okay, they may be a little different. I don't know. They might just say this. I haven't even looked. I don't have the book out in front of me. I just have my notes out in front of me. But they might write it like this, or they just might say x cannot equal 2. I'm not really sure. Peyton, you're looking it up, right? So let me know when you find that out. All right. Everybody got that? Let's keep going. We got some more to do. Let's do another example with this thing. What if I do this? What if I said c equals 2 pi r? And it says, find the domain of the radius. Okay? Do you know what c equals 2 pi r is? You guys had geometry either last year or year before, right? A couple years ago. The radius is half the diameter. That's true. What's the c? Circumference. What does that mean, the circumference? The distance what? Around. It's not from the midpoint or anything. It's around the circle, right? It's the distance around the circle, okay? That's circumference. The radius, okay, I'll just try to draw a little circle here, right there. That little bit right there is the radius, okay? Now, the radius has to be a certain distance, or it's got to be a distance. Let's say it that way. It has to be a distance. Okay, so what does r have to be? It's got to be what kind of a number? So the domain, it's got to be what? 45? Oh, 0.5? It can't be 0.4? It's got to be positive. Very good. The radius has to be positive. Can the radius be a negative number? No, because the radius is a distance. You can't have a negative distance, okay? It's got to be greater than what? Every positive number, we talked about this yesterday. Well, yeah, yesterday. It's got to be greater than 0, right? So how would we write this? We would say r such that r is greater than 0. That's the domain of the radius in c equals 2 pi r. So you got to know a little bit about what r represents, all right, to figure that out. That's your domain. Basically, you're telling whoever's looking at this, r has some restrictions. The radius of a circle has restrictions. It can't be 0. You can't have a circle with 0 radius. Then you wouldn't have a circle, would you? Okay? Could you have a circle with 0.01? Sure you could. Okay? As long as it's a positive number. You cannot have a radius with a circle of a negative radius. So that's domain. Believe me, we're gonna do a lot more with this. In fact, last year, I subbed for Mr. Rao for a few days. Maybe you guys were in one of those classes. I subbed for the college algebra class, and we were talking about domain, but it was way more complicated than what we're doing here. But if you understand this little bit, it's going to make domain, when it gets more complicated, it's going to make it a lot easier for you. Okay? Understand the basics, the foundations. That's what's so important about math. If you understand the foundations, then it's easy to build on those foundations. And that's all this review chapter is. Okay? It's just foundational stuff. But I think it's important to do, so I figured that we would do it. All right, let's go to something completely different. Yes?
Can you go to an example where x is squared?
Oh, if you have x squared? Okay, let's talk about that. What's the domain of x? Is there anything that x cannot be? Can you square a negative number? Sure you can. Okay, can you square 0? What's 0 squared? 0. It works, okay? Can you square a positive number? Absolutely. Is there any number that can you square a square root? Sure. Okay, yeah. Is there any number? Nope. So what's the domain? It's just all the real numbers. So you would put the domain is, oops, that was a little sloppy, x, okay? And then there's no restrictions on it. So I don't need to put that such that x has to be whatever, right? It could be anything. It could be a negative number. It could be a decimal. It could be a fraction. It could be anything, all right? So you could always square that, okay? All right, we're not going to go through all the possibilities, but that's that one. All right, let's talk about the law of exponents. I need to go through this a little quick now. Exponents. I'm going to put laws of exponents, okay, because there's going to be a few of them. Okay, the first one is this, a to the n. What does that basically mean? It means a times a times a. How many times? 3?
No.
This is an n. This is an n. If this was a 5, then you put 5 a's. If it was a 7, you put 7 a's. If it's n, you would put what? N number of a's. All right, so I'm going to put a dot, dot, dot. This is kind of weird. And then how many do we have here? How many do we have? We have n numbers. So a quick example is a to the third. What's a to the third, or a cubed? A times a times a. All right, you see that? Does that make sense? A to the n? N just represents any number. All right, so a to the fifth, I'd put 5 a's down. They're all multiplied. If I put a to the 100th power, I'd put 100 a's down. I'm not going to do that, but that's what you would do. That's your first law of exponents. That's pretty basic. Here's another law, excuse me, of exponents. Bryce, you have a calculator out, right? I saw it. Type in this. Do you know how to do an exponent on there? Put a to the 0 and see what, not a, put any number. Excuse me, must be my COVID. Just kidding. I'm just kidding. Don't sue me. All right. That's right. Okay, it doesn't matter what. So what did you put to the 0 power? You put 5 to the 0. Put like 1,000 to the 0. See what you get. 1. It doesn't matter. You put negative, well, if you did this, if you put like negative 3 in parentheses to the 0, what do you think you would get? A 1, right? Anything to the 0 power is 1. Now, what if I did this? What if I put negative 5 to the 0? What's that? What's being taken to the 0 power here? Is the negative being taken to the 0 power? Nope, just the what? Just the 5. So you got to keep the negative. In this situation, you got to keep the negative here. What's 5 to the 0? It's 1. So if you have a negative outside of here, 5 to the 0, that's going to be negative 1. Okay? If I had more time, we'd probably go through and maybe show you some examples of how you get something to the 0 power is 1. But, all right, I'll show you real quick. I'll just show you a quick little example. Okay, so what if we had x to the third. Well, I'm kind of skipping ahead a little bit. That's all right. We'll do this anyway. And over x to the third. Okay. Do you remember what the rule is for this? You remember what the rule is if I had like x to the second times x to the third. What's that? X to the 5th. Because what do? You multiply these together, you add the exponents. So when you divide, what do you do with the exponents? You subtract. That's right. So no, you don't add on division, you add on multiplication. Okay, on division, you subtract. So it's 3 minus 3. So what is that? X to the, it's supposed to be a 3. What's 3 minus 3? 0. And what is this? What's that equal to? What's anything divided by itself? It's equal to 1, isn't it? So would you agree that x to the 0 is equal to 1? All right, it's just a little demonstration. It's not really a proof or anything, but it's just a little demonstration on how x to the 0 is equal to 1. All right, that's free of charge. I won't charge you for that one. That wasn't in the book. All right, let's change colors. Let's do another definition. A to the negative n is equal to 1 over a to the n. All right, that's supposed to be an n right there. All right. So write that down. That's one of our laws of exponents. That's pretty important. So let's stick a regular number in there and see what we get. So let's go 3 to the negative second. So if I have something, it'll say like evaluate, I think is what they usually say. Evaluate. 3 to the negative second. It's not just 3 to the second. What is 3 to the second, by the way? Or 3 squared? 9. 3 times 3, okay, is 9. So is this a negative 9? A lot of people do that. A lot of people say, oh, I see a negative. That means my answer is negative. All right, 3 squared, I know that. That's 9. It's got to be negative 9. Is that the rule for my exponents? Nope. All right, it's this right here. So basically, here's what I like to show students. Again, I keep saying this, but this could get a lot more complicated. But I'm going to show you the real basic way to do this. What I do, if you see a negative exponent, you don't want to write it as a negative exponent. You want to write it as a positive exponent. Okay, so what I do is this. I take it and flip it. Okay, flip it to the bottom. And then when I flip it to the bottom, I got to change something. I can't just flip it to the bottom and expect it to stay the same. If I flip it to the bottom, then I'm going to multiply it. And then what I do is I change the exponent from a negative exponent to a positive exponent. See what I do? Just flip. If you have a negative exponent, you just flip it. And then you got to change the sign of the exponent. It's as easy as that. Okay? What's left on top? If I took this thing right here and flipped it to the bottom, what's left on top? Just nothing? A 1. That's right, because 1 is always being multiplied by something, isn't it? Okay, so 1 times that. So what do I have now? 1 over what? 3 to the second, or 3 squared. And I can simplify it. What's 1 over 3 squared? 1 over 9, and there I go. All right, you see that? You could go by this law right here and say, well, it says that, and I put it over here, put a 1 on top, all that kind of stuff. But I think it's easier just saying, flip it, change the sign, and then simplify. You got it? Okay, that's all that negative exponent tells you to do. It's just flip it. What if it was down the bottom? What if it was 2 over, I don't know, I'm just making this up, 4, I'll keep it easy, to the negative second. What if I asked you to simplify that? Well, what do? I flip it, because I got a negative exponent, right? So I take this, and I flip it to the top. What's left on the bottom after I flip it? What's left on the bottom? Come on. No. Just a 1, right, because it's 1 times this. Do I really need the 1 on the bottom if that's the only thing down there? Not really, okay? Now, when I flip it to the top, I got to change it to 4 to the what? Positive second. What's it doing to that 2 right there? It's being multiplied. Remember, please excuse my Aunt Sally. What was the P? Parentheses. What was the E? Exponents. So what do we do first here? We do the exponents first. Okay? So what's 4 squared? 16 times what? 2 equals 32. And that's my answer. So 2 over 4 to the negative second is the same as 32. Mac, you getting all this? Getting it by osmosis? It's coming from your book up and through your brain. Somebody tap him. Wake him up. Billy, tap him. Get up, Billy. Tap him. All right, that works. Matt, get your head up, please. Come on. Have a little respect for me. You don't want me turning the other way when you drop back and throw a touchdown on Saturday, do you? You want me paying attention, getting the picture, don't you? So watch me, okay? Let's do another one. So we're gonna do some more. I didn't ask for anything. I just want you to pay attention. That's all I want you to do. So if you're gonna sleep, I'll call you out. All right? I told you that from the beginning. All right. So let's do some more laws of exponents. These are this first one is called the product rule. All right. And so here it is. This is really important. We're going to use this a ton. So a to the m times a to the n. We actually already talked about it a little bit ago. All right. When you have the same base, do we have the same base here? Absolutely. They're both a. So we keep the base the same. And what do we do with the exponents here? Do we multiply the exponents? I mean, this is a multiplication problem. Do we multiply the exponents? No. What do we do with the exponents? We add them. Remember we had the 2 and the 3 earlier? Okay, it's the same thing. So what's the rule? It's m plus n. Let's do a quick little example. What if I have x to the negative 3 times x to the positive 5? And again, this is a multiplication problem. It has the same base. This only works if you have the same base. X is our base, so we keep the base the same. What do we do with the exponents? Negative 3 plus 5, and then that is x to the second, or x squared. So that's the product rule. I'm sure you've seen that since Algebra 1, so we'll continue. Let's do the power rule. That sounds cool. Power rule. So here it is. Again, these are extremely important. You're going to use these a ton this year. Now, this is a little bit different. You got a to the m power, and that whole thing is being taken to the n power. So what you do here is now you actually multiply the exponents together. So m times n. So that's the rule. So let's do one. Again, I'm just making this up. I got examples I got from the book, but I'm just making some stuff up here. So let's say you have 3. Let's go 2, make it easier. 2 to the second, in parentheses, to the third. Okay, just try to make the numbers as small as possible. So what if we have that? Well, you have a base to the second power, and you have that power taken to another power. That's why we call it the power rule. We have a power taken to another power. You got it? An exponent to another exponent. So what's the rule? Multiply the exponents. Keep the base the same. Multiply the exponents. So what is that? It's going to be a 6. So I'm just writing every single step. You really probably wouldn't have to do that little step right there. Just do that in your head. This is in your head. So 2 times 3, it's 2 to the 6. And I don't know, what's 64? Is that right? I think 2 to the 6 is 64. Anybody know? I'm pretty sure. Try it. Bryce, you awake? You're the calculator, man. Put it in there. 2 to the 6th power. Do you know how to do that? All right, good. I was right. Oh, let's do this one. I don't know if this has a name. And it's to the n power. Check this out. You have 2 numbers being multiplied inside of here, and everything's being taken to the n power. So listen to what I just said. Everything inside of there is being taken to the n power. So how do you think you would rewrite this? So a is being taken to what? The n power. B is being taken to the what? N power. And that's it. Okay? So that's that rule. It doesn't have a name. We're almost finished. This is called the quotient rule. Quotient means what? Division. Yeah. Division. So it's a to the m over a to the n. We already talked about this earlier. Again, these all have to have the same base. So you keep the base the same. What do you do with the exponents right here? We talked about this about 10 minutes ago. You add them? I thought we added them when we did the whatever rule, the product rule. When they were being multiplied, we added them. Okay, very good. It is subtraction. All right, let's scooch this up a little bit. You subtract the 2 numbers. So you take the top one minus the bottom one. Let's do an example. X to the 7th over x to the 3rd. That's an easy one. Okay, Same base, keep the base the same. What do you do with the exponents? Subtract them, and it's just x to the what? 4th. Everybody with me? I know this is a little long today, but got to stick with me. And I know it's dark in here. That doesn't help. But that's your answer right there. What if you had some negative exponents? What if I had x to the negative 3rd over x to the 5th? Let's do that one. Yeah. You can't see that? All right. I can change that color. Is that better? All right. Thanks for letting me know. All right, let's do this. What's the rule? X to the what? What do I do with those top? I take the top one, subtract the bottom one, and what do I get? X to the negative 8th. There we go. What do you think? One more, and we'll be done. A over B to the n power. It's kind of like this one right here. Do you see that? Everything's being taken to the n power. Well, everything's being taken to the n power here, but you got a division, don't you? So it's going to be what? A to the n over, well, b is also, it's in parentheses. Everything in here is being taken to the n power. So you could also write it b to the n. That's another way you could write it. All right. So the homework that I gave you yesterday, I'm just going to rewrite it again. It's page 27. This is going to be due tomorrow. I will collect it tomorrow. Okay, so page 27, and you're doing numbers 39 to 83, but you're doing all of them? Just the odds. And that's your homework assignment. If you didn't finish it, I believe all the way up to 83 is the stuff that we covered today. All right? So if you did finish it yesterday, hang on to it. Okay, I'm going to collect it tomorrow, so don't turn anything into me today unless you have late stuff from the other day. Okay, thank you. Thank you. Just drop it.
I'm not going to be here tomorrow because I'm going to get out later.
Yeah, if you're not going to be here tomorrow, I'll take it today. Let me stop recording.